So it's 4 o'clock, so let's get started. Hopefully everyone can hear me. Waiting for a sign.
We sure can hear you, Stefan.
Okay, great, thanks. So good afternoon and welcome to INFOStudio. First of all, thank you for joining us today. I'm Stefan and I'm your host for this session. INFOStudio is a digital place where we dive into topics like design, tech, and agile, and share our knowledge and experiences and lessons learned from real-life business problems. The topic for today is best practices to create your scalable software architecture. Over the last decade or so, we've moved from bare metal to virtual servers to containers to fully managed cloud infrastructures, and scalability has become an increasingly more important topic, and with that comes its impact on architecture. In this webinar, we will share our vision on how to achieve a microservice architecture which sets you up for an evolutionary architecture from the start, support continuous change, and build a flexible and scalable platform. We will use real-life practices from OV-fiets as examples and give you some insights in how we are able to handle thousands of transactions per hour. You will learn about the basic principles, and we will share our take on applying scalable and evolutionary architectures and how it helps ensure you can continue to provide value to an increasing number of users. Lastly, we will talk about some of our key takeaways from working at scale. This webinar is intended for software engineers and architects looking to gain some more knowledge about scalability and how we put it in practice, but also for IT management looking on how they can move towards a more scalable platform. Let me quickly talk a bit about Info and what we do. Info is a full-service tech and innovation agency, and for over 25 years, we've been helping our clients create successful innovations and end-to-end solutions where we have a history of helping with the development of products and services from initial vision to implementation. What does end-to-end look like? At a glance, our proposition goes from high-level advisory to strategy to delivery in a cyclical manner, depending on the type of work we're doing with our clients. End-to-end means that we are part of everything from early vision and goal setting to initiating software design processes to, in the end, delivery, where we combine lean and agile working methods to develop digital products and services. Now let's continue. For this INFOStudio, I'm joined by two of my colleagues, Bas and Cyril. Bas, Cyril, feel free to introduce yourselves.
Yeah, thanks, Stefan. My name is Bas de Wit. I'm the technical lead for the backend software engineers with Info. I've been in the industry for over 20 years now. And in that time, I've been working on many different technologies and platforms, and with Info for the last 6 years. Over to you, Cyril.
Yeah, so my name is Cyril Roos. I'm a system engineer and a DevOps engineer. I've been working for Info for the last 6 years. I'm mainly involved with the NS project right now.
Okay, thank you, Bas and Cyril. And to introduce myself further, again, my name is Stefan, and I'm a technical lead as well here at Info. I'm a former design technologist turned front-end software engineer, though over the last 5 years, my focus has been on full-stack development using Node.js. Okay, before we dive into today's topic, there are a couple of things that I'd like to mention just to get this session over smoothly. This session is being recorded. We will send you the link to the recording afterwards. During this session, you aren't able to use your microphone, but if you have any questions, feel free to use the group chat option anytime during the session. and questions will be discussed during the webinar. Any questions that we aren't able to answer during the session due to time constraints will be answered in a recording Q&A and will be shared with you along with the recording. So let's dive into today's topic and start with a short introduction. Depending on who you talk to, scalability can have a different meaning. When we talk about scalability in the context of this session, then we're talking about the system's ability to deal with changes in workload without a noticeable impact on users. Whether you're just starting out with a new project or if you're already managing a large system or platform, you want to be in control and able to manage growth at all times. This requires a system architecture that is capable of evolving over time while you maintain the same level of service to your users. Now, we're going to be showing a couple of examples during this webinar, and here's a very current example from OV-fiets. In red, you see the bikes that are rented out, and in green, the available bikes rented for the Amsterdam Central Station, one of the bike locations that is. And it's clearly to see from this moment in time that the corona virus has its impact with the lockdown. And if you look at King's Day, you really see that there's a lot less traffic on the platform and there are a lot less bikes rented out during the day. This is just a very small example of the scalability of our platform that we built for OV-fiets. And again, we will be revisiting those examples later in this webinar. Now over to Bas, and he will talk you through some of the basic principles.
Yes, thank you, Stefan. So go and share my presentation. Yes, the basic principles of a scalable platform and evolutionary architecture. What do we mean with the scalable platform and evolutionary architecture? So first of all, when we talk about scalable, we are talking about a platform that has to be able to cope with different workloads. That means it has to be able to handle high loads when the system is under some stress, but also it should be able to handle small loads efficiently without consuming unneeded resources. The platform itself here is the collection of services and infrastructure that we have in place for running your business application. Evolutionary, that we'll be talking about, is the gradual change caused by internal and or external forces putting pressure on the state of a system. It means we have to make changes to the system. And for architecture in particular, it would mean that we're forced to constantly evaluate our previously made decisions. And architecture is the how we have created the services, how they've been hooked up together, and how they're exposed to the outside world. So how can we set up a scalable platform? Firstly, we should start with planning for scale. We have to think of scalability from the start of your project. And we have to make a decision on the requirements that we have around scalability. Is it that your system has to be able to handle a certain workload, or is it that it has to be scalable for robustness with built-in redundancy? So one of the ways we can look at that is using modular or microservices architecture. That's an architecture that sets up like the picture really shows us with different blocks, multiple services that make up your complete business application. Each microservice, here represented by one of those little blocks, does one thing, and it does it well. And it would not be concerned what other services are doing. They should be loosely coupled, meaning they're only minimally dependent on each other, and others can be replaced without this particular service having been negatively impacted by that. Creating a loosely coupled architecture is always a hard thing to ensure that it is there, but by choosing the correct boundaries of your services, you can minimize coupling, and you can make each of the services scale better. Another reason to actually consider microservices architecture is that it's very well supported within the community. All the well-known cloud providers, AWS, Azure, Google, and others, they all support it on their platforms, and it, as we do here with Info, we can run it in-house on bare metal. There are also, for instance, Docker containers and orchestration networks, such as Kubernetes and Mesos Marathon, that we can use to run microservices on. The statelessness is that your application is not dependent on existing state. The state is not stored in a session, for instance. It's passed in by the methods called onto that service. That means that each of the methods will be independent and will also be, or should also be, made system idempotent, meaning that the overall system state remains the same after one or many calls of the same method with the same context. Statelessness also allows for multiple instances of the same module or service to operate at the same time without interfering with each other. It's a key component required to make a system scalable. Auto-scaling is where services are automatically started, scaled up, or stopped, scaled down when demand on a service is increasing or it's falling. And then error recovery. Besides scalability, we should also think about error recovery. What will happen if a microservice or a module fails? How will it recover from that? Can be that the whole service is removed and restarted automatically, or it is got to be handled in another way, but it's definitely a thing to keep in mind. Then the communication between microservices. That's for a scalable platform. We definitely need to have a consideration of what each of the, how the communication between the microservices is going to be handled. Is it going to be synchronous, waiting for the other microservice to finish its work before continuing with your own work? Is it asynchronous, a send and forget type system, or is it event-based, where each of the microservices reacts to events that are generated by each other. Now there's multiple options, but each of them have their own challenges. And then what does it mean then to use an evolutionary architecture? Evolutionary architecture is not the same as a scalable platform, but these come very, they rub cheeks, so to say. But an evolutionary architecture is supporting incremental, guided change across multiple dimensions. It is the process where we manage changes to the overall system architecture. Changes that can come from external factors. You can think, for instance, of something simple as a library upgrade that is pushed onto us because of a bug fix or a security fix that's been done in a library. Always important to get those into your system, integrated into your system. Or it could be an internal change, like a requirement for a new feature that just pushes the boundaries of your current architecture, where we have to look at how to solve this with a modification to the initial architecture. So how are we actually going to be able to handle an evolutionary architecture? To actually handle the evolutionary architecture, we define fitness functions. Fitness functions are used to summarize how close a given design architecture solution is to achieving a set of aims. So fitness functions. We can look at fitness functions from a number of directions. One way is use tests, unit tests, integration tests, etc., to check if a small unit of our code, if that is fit for function. We might want to verify the throughput of some business code and verify that that is actually fits with the requirements that we've set for our system. On the other side, we have the metrics. Metrics from a production system that can be used to verify fitness in a production environment, where we can verify that the behavior of the production system conforms to what we have set for it. Think of, for instance, response times on user requests, etc. Then there's more types of fitness functions we can think of, such as code quality checks. They can be used to verify that your code is maintainable, or architectural checks, which can be more broadly defined as checks that we do on the way that services are created, if they follow certain standards, if the procedure to use them, if the documentation is correct, etc. Those are generally more manual checks, but the more we can automate these fitness functions, the better we will be able to evolve our architecture, and sooner we detect if our fitness functions fail. Then let's have a quick talk about the minimal viable product as a evolutionary architecture. So as we see, we have our picture of minimal viable product with a skateboard that evolves in a number of steps to a four-wheel drive all-terrain vehicle. The way we should use the minimal viable product technology or procedure is to tackle, that's there to tackle difficult things first. For instance, with the skateboard, we have to create the wheels, both wheels first, but those wheels will still be there when we have our four-wheel drive. Then it's an evolving system, so we will want to start with a product that is good enough to go and to roll away on, but it's not going to have all the features that may be required in the end. Then again, the process of it's the idea of a minimal viable product is as well to avoid premature optimization, because we don't know what the future is going to bring, and we want to evaluate only once we've put something out there and improve on our architecture and our product as we see evaluation data come in. And that also means that we want to evolve as we need it. So not necessarily improve only, but also evolve. And our roadmap that we might have set initially to create a four-wheel drive all-terrain vehicle may turn out to be that we need to change tech halfway through building our system, and we go end up with an sports car instead of an all-terrain vehicle. And these are for now the things I wanted to share with you. Are there any questions, Stefan?
I haven't seen any questions coming in your group chat just yet, but I have a question for you. So traditionally, software architecture is kind of a thing that happens upfront. It's often long-term planning as well, and evolutionary architectures are a relatively new thing. How would you start with implementing an evolutionary architecture for a current existing system?
Yeah, that's an interesting question. If there's a system in place and architecture has been set up, obviously they're a little bit depending on what type of system it is, but evolutionary architecture itself doesn't mean that you can't start doing it straight away. The idea behind the fitness functions means that you set some boundaries to your requirements and what your system should look like. Obviously, these boundaries, they can be set on any system already. And by setting them, you already are pushing yourself to have a think about what your architecture should look like. So then the first steps are to decide what is the most important fitness function that you want to tackle with your system, and then you'll have to come into the evaluate, evolve, and change loop, and tackle things, small things. See what is the first, what is the next fitness function or the first thing that needs to be tackled according to your own goals. From there, pick it up and make changes to your architecture. As architects need to do, but similarly to the minimal viable product steps, make sure they're small and manageable, and evolve as you go.
Yeah, indeed. There's a question coming in. Two questions even. One question is, can one move to an evolutionary architecture from a traditional one? Any considerations to keep in mind? That's a good question, a follow-up question.
Yeah, so basically saying the evolutionary architecture only makes you try to make sure that you expect change. Change can come from any side. So if you architecture your system up front completely and think it through to the end, you end up that you are implementing it halfway and find that your requirements have changed, or things have changed under your feet. So you have to make adjustments at that point. Evolutionary architecture only tries to tell you, be aware that things do change. Make small architectural decisions. Don't try to make a full architectural picture of everything. Make it as far as you can see for the moment. Sure, have a think about the future, but do not feel that you can make a change easily. And as we've set out with the microservices, the idea with that is that we can pick up one of the services if we find that one of them is not fit for purpose anymore. We can go ahead and replace one of the microservices only, and not the full set of your whole application.
Yeah.
And the other question?
Yeah, the other question, how do you decide where to draw the line in regards to an MVP? I find that it's quite hard to do just the minimal. Any tips for making choices, what really is necessary and what's not? Ooh, that's a hard question to answer.
Yeah, this is a very hard question. I think these decisions always seem to be very difficult, particularly from a business point of view, because obviously as a business you would like to give your users as many features as possible with the first release of your product.
Yeah.
But we do find that as soon as a product is say out in the wild and it's used by people, that there are usability requirements coming in, or users have kind of different expectations of your product than you would have yourself already decided up front. So it is it is important to actually make your minimal viable product quite minimal, and my tip would be make it as minimal as you can. Get it out there as soon as you can. And yeah, other tip is really, it is a discussion to have with the business, because they have to in the end support what's being put out there.
Yeah, definitely. I don't see any new questions, so Cyril, maybe you can take over.
All right. Let me quickly share my screen. Okay. So I want to talk to you about the OV-fiets case. We've been working for the NS, the Dutch Railways, for a couple of years on a fleet management and transaction platform for the bicycle products, which are OV-fiets, which is a bike rental system located on most train stations and a lot of public transport hubs. There's also the bike parking services, with or without subscription, on the locations managed by NS. These are all very successful products for NS, and the popularity is really clear if you've ever been in a location in a major city on a weekday. The bike garages are full and OV-fiets is probably gone. OV-fiets has been growing yearly around 20%, with 4.2 million rentals in 2018. Last year we had even 5.2 million rentals.
Cyril,
this year we would have.
Your camera.
Sorry? My
Could
camera.
you turn
Oh, yeah, sure.
Cool.
Oh, sorry. Here we go. Okay. So this year we would have seen similar growth, but of course it's not going to happen this year because of the current situation. Apart from the global pandemics, the growth is mostly limited just by the physical space available. So if a location is expanded or rebuilt, it is immediately filled to the brim with bikes. So that's what mainly limiting the growth right now. So these numbers are just for OV-fiets. Oh, sorry. These numbers are just for OV-fiets. We also handle the parking transactions, but I'll set those aside for now. I'll keep those out of the conversation. The platform was very complex. It was scattered over multiple suppliers and it lacked integration. It became very clear over time that something needed to happen to be more in control and to be able to keep up with the growth. So around 2016, NS came to us with a question to give this to revisit the system and the platform. So what we did, we started building a fleet management system to provide insights for the back office and customer service on rentals, on parkings, on vehicles, and over chip cards. And on top of that, we built and integrated the transaction system that handles the communication with terminals and the invoicing. This is all based on microservices running in Kubernetes. It contains about 25 microservices currently, each running with multiple replicas to provide failover and highly available solution, which is also scalable, of course. So how did we approach this? First of all, we got acquainted as a team about the product, starting from the very visible public side. We slowly start peeling off more layers and talk to a lot of people in different roles, just to get a good grip on all angles and problems they encountered, so we get a holistic view, overview of the OV-fiets service. And this includes the numbers as well. So how is the product actually used in practice? So in this case, you, for example, see the daily pattern of rentals on a single location, in this case, Utrecht Centraal Jaarbeursplein. And as you can see, it follows a quite predictable pattern daily, with a spike in the morning rush hour and more spread out hump in the evening rush hour. And outside of those moments, it's actually mostly calm. So based on projections of past usage and future plans, we could ballpark predict the number of transactions that the platform would handle in 5 years' time. Combining that with the envisioned microservice architecture for the environment, we made estimations on the required resources that were needed, and we worked up our way from there. We defined performance goals. We set up load performance tests to verify the performance of the platform. We picked the busiest minute of rush hour traffic of a single year. We doubled that amount and used that scenario to play multiple times against a dedicated environment, just to verify if everything is working as intended. We have identified the bottlenecks this way, but currently those are above our performance goals. So we should not encounter any performance issues even during an insane morning rush hour. And it's not really necessary to optimize something that is out of reach currently. There's also no need for dynamic auto scaling on this platform. There's a physical upper limit on the number of OV-fiets in service and the number of parking spots. Concurrency is also reduced as well, because on the busiest locations, people are just lining up in the rush hour to get the card scanned with a handheld terminal. What's also very important is to set up a feedback loop. So everything that is running is monitored, is measured, is all metrics are collected. What the system is providing, including logs, and let that flow back into the build, to what you're building. And of course, we keep redefining and evolving our performance goals. More and more locations will require scanning of OV chip cards for parking your bike. And OV-fiets bikes are getting replaced with smart locks that will increase the messages exchange with the platform a lot. We'll probably have a lot more room for concurrency as well, as there's no need for the employee in the location to be involved. So, what have we actually learned? Back to you, Stefan.
I was actually expecting a Q&A. So if you don't mind, yes. I'm looking for questions. I haven't seen any questions coming in yet, but I have a question prepared for you. Coming from the trenches, you probably have a couple of good war stories to tell. Perhaps you want to share some of the pitfalls or mistakes that you've encountered along the way, and how you tackle those.
Yeah, I'm not sure if you want to share all my mistakes, but of course, building a true microservice is hard. But yeah, we're doing it with an agile development style, metric-driven optimization. So that way, we were successful, I guess. This allowed us to keep adapting and even refactor the architecture if that was needed. So, for example, we started adding services over time that were relying on each other. But over time, it became clear that the architecture became too complex, as more and more microservices were depending on each other, and communication was harder to deal with. So I think about a year ago, we introduced streaming for all communications that could be handled asynchronously. So that improved the system and made it less complex and more maintainable.
Okay. Any other questions? Here we have a question. How do you decide what to measure and how to deal with the measured data? The quality of data depends on what your goal is and the data, right?
Yeah, exactly. So you need to identify what you want to measure and what your goals are. Otherwise, it's no use to measure it. Of course, things that are causing problems, you should definitely measure. Try to prevent things that are breaking or are hitting a limit that you know of. Yes, set thresholds. So try to work towards a goal instead of optimizing something that is not needed.
Yeah, and then I guess when it comes to quality of data, just revisit the data, see if it contributes towards the goal you set, if you actually are measuring towards your goal, and improving again as you go along.
Sure, yeah, exactly.
Okay, thanks. I'm just gonna share my screen again. If I can find my cursor, yes, here it is. And let's talk a little bit about some key takeaways from the different talks. So, Bas, perhaps you can share one or two key takeaways.
Yeah, the main takeaways that I would like people to remember from the evolutionary architecture and scalable platforms is that the future is unknown. There's change is always coming. So architecture has to the architecture that you set up has to take that into account. You cannot architect for 10 years in the future. So do not even try. Make sure you define some fitness functions that that will define what your architecture should aim for, and evolve as you need. That I think is the main takeaway.
Okay, thanks.
Cyril.
Cyril, yeah, perhaps you have one or two last key takeaways that you want to share.
Yeah, sure. So I would say it's very important to get to know the product inside out, so you can focus on what is actually relevant. Collect a lot of metrics and make sure that those flow back into the development, so benefit can be gained. I would say don't be afraid to adapt, refactor, or even change the architecture.
Yeah, exactly. As Bas also mentioned, evolve,
exactly.
evolve. Yeah. Okay, well, thank you, Bas, and thank you, Cyril. That's all that we have time for today. If you do have any remaining questions, feel free to send them in via our emails that are listed on screen. We are more than happy to answer them. And we may do a Q&A recording, as mentioned at the start of this webinar, and send that out together with this recording. If you are interested in attending more of these sessions, our next INFOStudio is scheduled for Tuesday, the 19th of May, when the topic will be effectively managing your stakeholders and backlog using agile principles. More information can be found by visiting the link on screen. Also, please look for info on LinkedIn. We will post the link in the chat, and and we are soon going to ask for recommendations on the next subject for a webinar on design. Furthermore, keep an eye out for the schedule of the INFOStudio on the INFOStudio page for the upcoming webinars. This concludes today's INFOStudio. Thank you for attending. And again, the link of this recording will be shared with you in the upcoming days through email. For now, take care and bye-bye.